So we've just got a quick demo here of the hydrological cycle. This is sped up, it's actually slower for people to watch. That gives you an idea. Here's the structures side of things, so it's just a PowerPoint. People can go through looking at different styles, types of installations there are around the country and around the world. Just to give them an idea of maybe what's different outside their area and what other people are doing. How they're installed, how they work, etc. And a quick example of Stirling Well being installed. This is sped up and slightly shorter just to save time. Then we have staff gauges, purpose, and just examples of what you'll commonly find around the country. With the lakes, rivers, some are sloping, vertical, small streams, big streams, damage that can occur, floods, hard to read. And then an exercise, how to read several staff gauges. So students are asked to look at these and record their answer. So some of them are easier than others. Just the sort of thing you'll find typically in the field. Some are easy, some are hard, some are difficult off bridges. So it just gives them a bit of a cross reference of really what's out there and what to expect. And then instrumentation, what sort of instruments are out there, the different water level recording devices and housings. And just explaining, again this is a PowerPoint, what each instrument is and the sensors. And then a quick demo of a site inspection. So when you get to a site, what sort of things should you be looking for, covering, checking off, writing down. So just how to do these different checks, internal, external, reading the recorders, recording everything, staff gauge reading. And then communication devices, this is how we're getting our data back, so telemetry, different types of aerials. Site hazards, so again a PowerPoint just with some examples of maybe bad installations, dangers to look out for. Good, the bad, steep banks, hard to read staff gauges, difficult conditions. And after that there's a movie or video to watch, which students need to identify 16 hazards. So here's just a sped up version of a few of those hazards. So they need to write down, identify each hazard as they're numbered here. Catwalk, is this safe? Is it meant to be bent? Structures. Slippery banks, down to read staff gauges. Undercut banks, danger of falling in. And then we move on to current meter gauging. This is just a glimpse of a standard practice, setting up the instrument itself, preparing it, how to start at the banks, how to do multiple 2s, 6s and 8s. And then we have a flow tracker, so just the electronic version of the one before, which is stationary measurements, what that looks like. This is from the Sontex webpage. An ADCP stream pro gauging at a site. This is a fairly typical setup, how we should check the instrument, moving bed tests, actually do the measurement itself. So it shows the software and moving bed being carried, or compass being calibrated in this case. And then gauging being carried out. What it looks like in the software. And the results. So this is a survey module. This talks you through, firstly, how we should set up and use a survey equipment, automatic level in this case, the different instruments you're likely to use, most common, and then how to take a reading using the staff, looking through the level. And then we give an activity following up on that, which you have to actually enter in several screenshots or photos of levels. And it won't let you carry on until you get it right, so you have to enter in the, it's a bit of feedback from the students there. You get several goes and it tells you the correct answer if you get it wrong. And then there's several to do on that. And then lastly we have a actual station inspection. So we've got staff gauges, internal plumb bobs, benchmarks. So full levelling that you'd find at a typical site, involving 2 people like this. And how it's booked as well, either electronically or in a field sheet. So here we are levelling in the internal plumb bob. So now we're going on to rain gauge. So this is a typical rain gauge enclosure, fairly new one by the look of it, and how things are inspected, how the check gauges check the dipstick and volumetric flask. Remember, this is a shortened version of what's actually shown, but just how to do checks and setups and calibration of the gear in the field. And then we have an example of the NIWA calibration lab where the rain gauges are tested on their calibration beds here. What's involved, how they're checked, recorded. Different types of rain gauges. Just what it looks like, example when it's working. And another example just of a similar check being done in the field with the field calibrator. What to do on site, what to look for, how to check it before and after, how to clean it. So just what you typically would find in the field, what you should do as a technician at a rain gauge site. And some bad examples as well. Again, this is all shortened. And lastly, an optional really online learning, which would be the sediment side of things, which we're still doing more of. It is an example of suspended current meter gauging of a slack line to establish discharge, and after that a sediment sample done using the equal width increment method. Using an integrated method. So just an example. Remember, all these have a lot more to them. This is a shortened version. This is a demonstration. So more to come.